Okay, so our experiment for today is experiment 11, diastereoselective bromination of transinamic acid. So, before the procedure, okay, yung goal talaga natin for this experiment is to discuss isomerism. Okay, so isomerism, ka lang, naglalag ata, wait lang. Ayun. Okay. So, isomerism is the existence of compounds with the same molecular formula but with different structures. So, the word isomer is derived from the Greek words isos and meros, which means equal parts. So, the term was coined by the Swedish chemist Jacob Berzelius in 1830. So, we have two main types of isomers, the structural isomers and stereoisomers. Okay. So, before we go into the classification of isomers, okay, this is just, bakit ayaw mag, ayan. Okay. So, this is just, teka lang ha, ayaw ata mag screen share. Teka lang. Ayan. Okay. So, first, ayan, papakita muna natin yung importance ng isomerism sa real life. Ayan. So, we have the thalidomide accident. So, thalidomide is a drug marketed as a mild sleeping pill, safe, quote-unquote safe even for pregnant women. However, okay, the drug caused thousands of babies worldwide to be born with malformed limbs. So, positive results, sorry, doon muna pala tayo sa dalawang compounds. So, may dalawang isomers yung thalidomide. Okay? The R-thalidomide and the S-thalidomide. Okay? So, yung R isomer, yun yung may sedative effects. And then, yung S isomer, siya yung teratogenic. So, when we say teratogenic, yun yung magiging cause ng malformed limbs sa babies. So, ang nangyari sa thalidomide accident, okay, yung na-benta na drugs ay may equal amounts of the R isomer of thalidomide and the S isomer of thalidomide. So, ang dapat na ibenta lang talaga nila is 100% R isomer. Kasi yung S isomer, yung teratogenic. So, yun yung naging accident dati. So, they stopped selling thalidomide. Pero, after nun, okay, some positive results so that thalidomide can be used against leprosy in many developing countries, and it successfully controlled AIDS-related condition, and its effects on various cancers are under investigation. Ayun. So, that's the importance of isomerism. Magkaiba yung effect, kahit na pareho yung chemical formula, okay, minsan magkaiba yung effect ng isomerism sa, magkaiba yung effects ng isomers sa health natin or sa iba pang applications ng compound. So that's why we study about isomerism. Yung orientation kasi ng molecules nyo, ng compounds nyo in space can eventually affect the applications of those compounds. Yan. So that's the importance of isomerism. So sorry pala kung magkakaiba yung formats ng PowerPoint dito kasi etong slide na to kinuha ko lang sa dati kong slides. Ayun. So next. Okay, so let's discuss the different types of isomerism. So as we said earlier, the main types of isomerism are structural isomerism. Okay, same formula, same molecular formula, but different structural formulae. And stereoisomerism, same molecular formula, but the atoms occupy different positions in space. So sa structural isomerism, we have three subtypes: chain isomerism, position isomerism, and then functional group stereoisomerism. Okay? So, for stereoisomerism, we have the geometrical isomerism for double bonds. Okay? Optical isomerism are usually for single bonded structures. And then may isa pa, conformational isomerism. Mamaya natin i-discuss yung tatlo. Okay, so for structural isomerism, again, we have the chain isomers. So the chain isomers differ in order in which the carbon atoms are bonded to each other. So for example, N-hexane and 2-methyl pentane. Okay, so let's draw hexane and methyl pentane. Wait lang. Okay. So for N-hexane, wait lang. Ayan. So, this is N-hexane. And then, 2-methyl pentane. So, this is 2-methyl pentane. So, both of them have the molecular formula C6H14, okay? But they differ in order in which the carbon atoms are bonded to each other. As you can see, straight chain yung hexane, and then 2-methyl pentane, meron kang methyl substituent. Okay? So, hexane and 2-methyl pentane are chain isomers. Now, for the second subtype, position isomers, they differ in the position of a functional group on the carbon chain. So, examples are 2-pentanol and 3-pentanol. So, 2-pentanol and 3-pentanol. Okay, so their molecular formulas are C5H12O. Okay, but as you can see, magkaiba yung position ng hydroxyl group. Yung sa 2-pentanol nasa second, and then yung sa 3-pentanol nasa third. So, yun yung position isomers. And then, for functional isomers, they differ fully in functional groups. So examples are pentanol and 3-pentanone. So for pentanol, okay, so this is pentanol. And then pentanone, so this is 3-pentanone. So both of them have the chemical formula C5H10O. But as you can see, yung pentanol, aldehyde, and yung pentanone ay ketone. So these two compounds are functional isomers. Okay. So, conformational isomers. So, dito na tayo sa second na type, the stereoisomerism. Same molecular formula, but atoms occupy different positions in space. So, for conformational isomers, so these are produced from the free rotation around a single bond. Okay? So, this is applicable only for the rotation around a single bond. Kasi yung mga yung bonds natin, okay, they freely rotate kapag single lang yung bond. Kapag double bond and triple bond, hindi sila nakaka-rotate. Okay? Kasi masyadong mataas yung energy na kailangan para mag-rotate sila. Sa single bonds, sa alkanes, maliit lang yung energy na kailangan para mag-rotate. So we have what we call the Newman projections. Okay? We can classify it according to the dihedral angles. Okay? So for the dihedral angles, we have the eclipsed and staggered. So pag eclipsed, magkakatabi yung substituents mo. And then kapag staggered, okay, relatively mas magkalayo yung mga substituents mo. Okay? So under the staggered classification, we have the anti and gauche. So the staggered configuration or conformation can be classified according to the positions of the bulky groups. Kapag magkalayo yung bulky groups with each other, okay, so our bulky groups here is are the two methyl groups. Kapag opposite sila or magkalayo, okay, it's called they are anti to each other. Now for the gauche, okay, yung dalawang bulky groups mo ay magkatabi. Okay, these two methyl groups are gauche with each other. So how do you view Newman projections? Okay, so for example, ito yung bond line formula or bond line structure ng ethane. Okay, this is ethane. So, this is CH3, CH3. So, yung bond line structure, yun yung side view mo ng Newman projection. Yung sa Newman projection, yun yung front view. Okay? So, yung carbon mo, yung nasa gitna, and then yung mga substituents, yung nakakabit sa gilid. That's why here, kapag view mo yung bond line structure, makikita mo na yung carbon yung nasa gitna, yung point, okay, sa center. And then, yung tatlong hydrogen, okay, yung nakakabit sa kanya. And then, yung symbol nung nasa likod ay circle. Okay? So, yung circle, this symbolizes na yun yung nasa likod na group. Okay? So, here, makikita din na tatlong hydrogen yung nakakabit dun sa carbon sa likod. Okay? So, sa conformation na to, this is eclipse. Okay? Kasi magkatapat yung substituents mo na hydrogen. And then, this is staggered dahil magkakalayo yung hydrogen substituents mo. Now, if we will classify this, if it's anti or gauche, this is gauche kasi magkatabi lang din halos yung hydrogen. Okay? So, anong relevance ng conformational isomers sa energy? Okay? So, ang nangyayari, alright, kapag nagro-rotate yung atoms mo around the single bond, okay, merong mga conformation na mas mataas yung energy compared sa iba. Dahil may tinatawag tayong torsional strain. So, sulat ko. Torsional strain. Okay? Kapag magkakatabi yung substituents, okay, based from your Newman projection, makikita mo na yung ibang substituents magkakatabi, yung iba magkakalayo. Now, we call it torsional strain. It's the destabilization effect caused by the overlapping of the bonding and non-bonding orbitals ng atoms mo na magkakatabi. Okay? So, basically, mas mataas yung torsional strain kapag mas magkalapit yung dalawang groups and mas mababa yung torsional strain kapag mas magkakalayo. Okay? That's why, kung makikita nyo dito, etong 4, yung eclipse. Okay? Wait lang. Ayan. So, yung 4, yung eclipse, siya yung may pinakamataas na torsional strain kasi kung makikita nyo dito, magkalapit yung dalawang methyl groups. Okay? So, siya yung may pinakamataas na torsional strain and therefore, siya rin yung may pinakamataas na energy na kailangan para ma-achieve tong conformation na to. Now, the most stable, okay? So, ito ang pinaka-unstable. Now, this, okay, yung 1, yung pinaka-stable. Kasi bukod sa staggered yung conformation ng Newman projection niya, okay, anti din yung dalawang bulky groups with each other. Therefore, nagdi-decrease yung torsional strain and nagdi-decrease din yung energy na kailangan para ma-achieve tong conformation na to. Okay? So again, no more na magkatabi or eclipse yung substituents and bulky groups mo with each other. Mas mataas yung torsional strain and therefore mas mataas yung energy na kailangan para ma-achieve yung conformation na yon. And kapag mas magkalayo yung bulky groups and substituents, mas mababa yung torsional strain and mas mababa yung energy para ma-achieve yung conformation na yon. Sorry. Okay. So, that's for the first subtype of the stereoisomers. Okay? So, that's the conformational isomers. Now, for geometric isomers, ito naman ay around a double bond. Kung kanina yung conformational isomers ay around a single bond, geometric isomers are for those with double bond dapat to. Around a double bond. Okay? So, we have two subclassifications ng geometric isomers, yung cis and trans, and E or Z. Okay? E for entgegen, or opposite, or Z for zusammen, or together. And this is governed by Can and Gold Prelab rules. Okay? I think na-encounter nyo na to sa lecture nyo, yung Can and Gold Prelab rules, pero i-discuss ko na lang ulit further later. Now, anong difference nung classification ng cis-trans sa E or Z? Okay? So, punta muna tayo sa cis-trans isomers. So, sa cis-trans isomers, alright, ito yung kapag nagko-compare ka ng dalawang compounds na may dalawang common substituents. Okay? So, for example, sa 2-pentene, okay, pareho silang merong dalawang hydrogen atoms na nakakabit. Okay? So, sa E or Z naman, balikan ko to mamaya. Pakita ko lang yung sa E or Z. Sa E or Z naman, lahat ng substituents na nakakabit sa double bond, magkakaiba. Okay? So, para di kayo ulit malito, sa cis or trans, okay, may dalawang magkapareho, tas dalawa lang yung magkaiba. Sa E or Z, lahat ng substituents around the double bond, magkakaiba lahat. Okay? So, balik tayo sa cis or trans. So, how will you know kapag cis or trans? So, basically, titingnan nyo lang yung bulky groups or yung magkapareho na substituent. Okay? So, kung titingnan nyo yung hydrogen, okay, nasa parehong side sila. So, kapag nasa parehong side, cis yung assignment ng isomer. Okay? Or kung titingnan mo naman yung CH3 and CH2CH3, yung parehong mas bulky na groups ay nasa same side din. So, cis yung assignment natin. Now, for trans assignment, okay, opposite yung same substituent and opposite din yung magkaibang substituents. So, cis and trans. So, another example, okay, kapag meron kayong cyclic na hydrocarbons, okay, so kapag nasa same side, ulit yung same substituents and yung magkaibang substituents, we assign it as cis. So, pag nasa opposite side, it's trans. So, ganito rin dito, cis, nasa same side yung dalawang substituents, and then trans dito. By the way, dito sa second example natin, 1,4-dimethyl cyclohexane, applicable lang na parehos, makakapag-assign tayo ng cis and trans dito kasi cycloalkane sila. Okay? So, hindi tayo nakapag-assign tayo ng cis and trans din kapag kapag at least meron kayong dalawang magkaibang substituents. Ayun. So, sorry pala, i-ano ko yun na dapat mag-assign kayo ng cis and trans kapag may at least 2 different substituents around the double bond or around the cyclic hydrocarbon. Ayun. So, pwede nga rin pala tong mangyari na CH3, CH3, and then dalawang hydrogen. So, basta makita nyo na same side, cis, and then kapag opposite sides, trans. Okay? So, for E and Z isomers, kapag may tanong pala kayo, tanong lang kayo. Okay? Again, pag E or Z isomers, tinitingnan natin kapag lahat ng substituents ay magkakaiba. Okay? So, again, kapag lahat ng substituents ay magkakaiba. So, how do we assign E or Z isomers? Okay. So, here, we have 4 substituents, F, Cl, Br, and I. Okay, so ang una nyong gagawin, hahatiin nyo sa gitna yung double bond. Okay? Then after nyong hatiin, titingnan nyo yung left and right side. Then magde-decide kayo kung ano yung may mas mataas na priority. So sa left side, okay, we have fluorine and chlorine. So we will assign using the Can and Gold Prelab rules. Okay? So kung ano yung may mas mataas na atomic number. Since Cl has a higher atomic number, ito yung priority natin for the left side. And then for the right side, we will compare iodine and bromine. Okay? So since iodine has the higher atomic number, okay? So yun din yung priority natin for the right side. And then titingnan natin sila as a whole. Okay? Kapag nasa opposite sides, yung priority groups, okay? So ito and ito nasa opposite side, the configuration is E. Okay? And then, dito naman, sa second isomer, okay, we will look at it again for the priorities. So, Cl and I ulit. So, kapag nasa same side yung priority groups mo, the conformation or the configuration is Z. Ayun. So, meron kaming mnemonic na ginagamit like sa E configuration, magkaiwalay. Ayun. And then, sa Z configuration, parang same side. Ayun. So, that's for E and Z isomers. Okay. So, do you have any questions so far? Okay. So, kung wala, let's go back to the discussion. Alright. So, tapos na tayo sa wait. Ayun pala, iba pala kay Ma'am Moni. Okay, magkazama. Okay, so for geometrical and conformational, tapos na tayo doon. Now for optical, so it occurs when molecules have a chiral center. Okay. So these are compounds with the same connectivity of atoms and different orientation in space, but which have non-superimposable mirror images. So it contains a stereocenter. The stereocenter is the atom that has 4 different groups attached to it. So subclassification includes the enantiomers, diastereomers, and mesomers, and we use absolute configurations, R or S, okay, to signify the configuration at the stereocenter. So for the absolute configuration, it can be described as R or S for each stereocenter, and it also follows the Can and Gold Prelab sequence rules for priority assignment. So, i-layout ko lang uli yung Can and Gold Prelab rules. So, again, the priority rules are the higher the atomic number, the higher the priority. And then we assign the priority to the next atom until there is a point of difference. For example, ito yung stereogenic center nyo or stereocenter. We assign the priorities based on the atomic number to all 4 atoms. So, the priority 1, okay? Yung A or B pala tayo. Tingin tayo dun sa A or B. So priority 1 is assigned to the atom or group of highest atomic number, and then priority 4, the lowest. Okay, so for example, A1, A2, A3, B1, B2, B3. So if two or more atoms are identical, okay, so A and B, okay, sorry pala, wait lang. Ito pala yung tinitingnan natin, yung X. Okay? So, A or B ay magkapareho. Okay? If two or more atoms are identical, designated as A and B. Okay? Look at all the atoms directly attached to the identical atoms in questions. So, it's designated as A1, A2, A3, and B1, B2, B3. So, we assign priorities to all these atoms based on the atomic number. Now, we will compare the highest priority atoms. Okay, you compare A1 with B1. So if A1 has a higher priority than B1, then A is a higher priority than B. Ayun. So mag-a-assign tayo until there is a point of difference. So in these examples, okay, so here, the stereogenic center ay ito. Okay? So, ang highest priority natin is yung bromine group, then yung oxygen from your ether group, and then the carbon in the methyl group, and then lastly, yung hydrogen. So, titingnan natin yung parang rotation, okay? Titingnan natin kung paano sila magkakasunod doon sa molecule. So, 1, 2, and 3. So, since clockwise, yung pagkakasunod-sunod nila sa priority, we assign it as R. Okay? So, kapag naman, for example, dito, okay, baligtad naman yung molecule. So, this is 1, 2, and 3. Tapos, yung hydrogen uli yung 4. So, kung ano yung orientation nila in space, according to the priority, so counterclockwise naman, therefore this is S. Okay? So, what if nasa harap yung hydrogen? Okay? So, for example, balik tayo dito. So, gayahin ko lang yung okay. So, for example, ganyan yung assignment natin. So, we will number this as 1. Okay? And then, this is 2. This is 3. And this is 4. Okay? So, yung assignment natin dito ay clockwise. Okay? Pero since nasa harap yung hydrogen, okay, babalik ta rin natin yung assignment natin. If it's originally R, based from our determination if it's clockwise or counterclockwise. Pero pag nasa harap yung lowest priority, pag nasa likod yung highest priority, okay, babalik ta rin natin yung original assignment natin. So, if yung original assignment natin is R, and since nasa likod yung highest priority, okay, we will assign this as S. Ayun. So, yun yung parang iba-iba rin kasi tayo. Kung medyo mahirap din kasi talaga i-grasp yung optical isomerism or yung absolute configurations. Pero this is what works for me. Okay? Pwede kayo mag-explore ng other learning tools kung saan kayo pinakamadali. Pero ang ginagawa ko lang, nag-a-assign ako initially, and then kapag wala sa harap yung first priority, binabaligtad ko yung assignment. Okay, so may question ba? Okay, so ayun. Okay. Okay, so meron kaming nilink dito na tutorial if you want to learn more about how you should assign absolute configuration. Or pwede nyo rin ako itanong kung meron kayong part na nalilito kung paano mag-assign ng R or S. Ayun. So, yan. Okay, we have other projections na ma-encounter nyo actually sa experiment na to. Okay, so we have what we call the Fisher projection. So, na-discuss nyo na ba to sa LEC? Na-discuss nyo na ba to sa Chem 33? Medyo. Okay. So, for Fisher projection, okay, I'll teach you how to interpret the Fisher projection to the bond line structure. Okay? So, kapag, ayan, nakalagay na dito, kapag horizontal lines, okay, yung substituents mo ay out of the plane, and kapag vertical lines naman, nasa plane yung substituents mo. So, for example, dito, sa example na to, okay, yung H and F mo, okay, so yung H and F mo, yung nasa left and right, okay, and then yung methyl group and bromine group, siya yung nandito sa taas and sa baba. Okay? So, kung titingnan nyo din yung figure dito, okay, yung nasa baba, siya yung nasa out of the plane, yung wedge, okay? And then yung nasa taas, siya yung nasa likod. Tapos yung X and Z, okay, yung dalawang nasa gilid, sila yung nasa plane. So, baligtad pala yung nandito sa text, sorry. So, dapat dito ay vertical lines, okay, vertical lines yung out of the plane, and then horizontal lines yung nasa plane. Sorry, baligtad. Ipapakorek ko na lang. Okay? So, vertical lines yung nasa plane, horizontal lines yung out of the plane. Wait, sorry. Vertical lines, yung out of the plane, horizontal lines, yung into the plane. Okay, baligtad yung nandito. Sorry, mali naman yung nasabi ko. Okay. So, another example. Okay, so kung may ganito kayong... Wait, ipat ako. Okay, so kung ganito yung compound nyo. Teka lang. Wait lang. Sorry. Ayan. Okay. So, for example, ganito yung bond line structure nyo. Paano nyo siya itatransform into a Fisher structure? So, dito, nasa harap itong OH na to, ito, and ito. Nasa harap sila. Okay? Now, the second step is that you'll straighten out the bond line structure. Okay? So, pag straighten out yung bond line structure, lahat ng nasa baba, okay, etong OH na to, and then yung OH na to, sila yung mga nasa baba, okay? Lahat sila mag-flip ng orientation. Kung nasa harap sila dito, kapag na-straighten out yung bond line structure mo, mapupunta sila sa likod. Okay? Again, kapag nasa baba sila, and then isa-straighten out nyo yung backbone ng bond line structure, okay? Mapupunta yung orientation nila sa likod. Alright? And then, how will you transform it to the Fisher structure? Okay? So, yung 1 natin is yung nasa taas. Okay? And then, kapag nasa harap yung OH, like this, nasa left siya sa Fisher projection. Okay? So, imagine nyo, kung nasa harap tong Imagine niyo kung yung bond line structure ay tinitingnan niyo yung top view niya para makita niyo yung Fisher projection. Kaya ganito yung I. Ayun. So, kung titingnan niyo yung top view, nung bond line structure na to, na straightened out na yung backbone, okay? So, makikita nyo na yung nasa harap ay nasa left, okay? Front, left. And then, yung nasa likod, back will be right. Okay? So, for the second carbon, nasa left yung OH. For the third, fourth, and fifth, nasa right yung tatlong hydroxyl groups. Okay? So, may tanong ba? Okay. So, ganun yung pag-assign ng Fisher projection. So, another example. Alright? So, paano naman baligtad? So, paano kayo magta-transform from Fisher projection to bond line structure? So, sa Fisher projection naman, okay, at ganito naman yung magiging view nyo para ma-transform siya to your bond line structure. So, ganito yung view. Titingnan nyo siya mula sa gilid ng Fisher projection. Now, kapag nasa left, again, sabi natin kanina, kapag nasa front, yung substituent nasa left siya. Ngayon naman, pabaligtad, so yung nasa left, yun yung nasa front. And then, yung nasa right, yun yung nasa likod. That's why yung hydrogen dito, nasa harap, and then yung chlorine dito, nasa likod. So, same goes with the OH here, nasa harap, and then yung bromine dito, nasa likod. Okay? So, that's how you transform the Fisher projection to the bond line structure. Now, actually, kulang pa to. Kasi kung gusto mong naka-zigzag yung formula mo or yung bond line structure mo, so, ang mangyayari, okay? So, magiging ganyan. Now, bababa yung second carbon mo. Yung carbon mo dito, bababa. Okay? So, ang mangyayari, if-flip mo ulit siya. So, magiging nasa harap mo ay chlorine and then nasa likod mo ay hydrogen. Ngayon, ito, hindi mo na i-flip kasi pataas na yung configuration niya din. So, magiging Br lang din to and OH. So, kung gusto nyong ipaulit, sabihin nyo lang. Okay? Pero, ayun. So, kung dito, again, yung configuration niya kasi ay paganito. Paganito. And then, dito, magiging paganon. Okay? So, magkakabaligtad sila. That's why mag-flip din yung front and back mo. Now, another example. So, ganito ulit. So, dito, sa second compound, yung hydrogen mo, nasa left. So, siya yung nasa harap. Hydrogen mo dito, nasa left din, nasa harap. And then, OH dito, yung nasa harap. Okay? So, kung gusto natin gawing zigzag, yung configuration, so, So, as you can see here, wait lang. Ayan. So, as you can see here, magre-retain yung dito kasi pag ganun pa rin yung orientation niya sa zigzag. Yung sa second, mag-flip ka kasi pag ganito na yung orientation niya. And then dito, hindi rin magbabago kasi pag ganun. So, sa second carbon lang yung magbabago since flinip mo na pababa yung sa zigzag pattern ng bond line structure. Okay? So that's how you interpret your your bond line structure to Fisher projection and then your Fisher projection to the bond line structure. Okay. So if you have any questions, okay, please just message. And then next, okay? So sa experiment, okay? So ang title na experiment natin ay diastereoselective bromination. So when we say stereoselectivity, it's the property of a reaction mechanism wherein reactant is converted to an equal mixture of stereoisomers. So, for example, in this reaction, okay, for E2 elimination reactions, okay, you have this compound. Okay? So, kapag nag-react siya through elimination, so ang mangyayari, yung major 88% ng product mo will have a trans configuration. So, makes sense na mas mataas yung percentage nito kasi mas stable yung trans configuration. And then, this will be the minor product kasi less stable yung cis configuration. So, you will have two stereoisomers of an alkene, but only one predominates. So, that's what we say when your reaction mechanism is stereoselective. So, sa experiment, kaya siya diastereoselective bromination kasi isa lang yung magiging major product natin sa huli. Okay? And yun yung i-determine nyo according sa data kung anong major product natin. Okay? So, alright. So, in this experiment, we will utilize the halogenation of alkenes. So, alkenes react with halogens, okay, to produce halogenated products via electrophilic addition reaction. So, we have the syn addition kapag sa same side yung pag-halogenate ng halogens mo sa alkene, and anti-addition kapag naman opposite sides yung nafo-form. Okay? Now, for this experiment, okay, we introduce stereospecific reactions such as the bromination of transenamic acid, and then we would like to identify which stereoisomer is formed based on the melting points. So, sa experiment natin, magkaiba yung melting points ng dalawang isomers. So, for the procedure, we will utilize reflux addition, okay, for the reaction, and then we will add cyclohexene. So, bakit tayo gagamit ng cyclohexene? Yun yung sasagutan nyo sa ATQ. Okay? So, and then we will use vacuum filtration to filter our product, then recrystallize it to purify further, and then determine the melting point to see what product was formed. Now, for the reflux addition, okay, makikita nyo na siya sa video, nasa experiment video na siya. So, the funnel, okay, an addition funnel, we call it an addition funnel, is incorporated into the reflux setup. So, a Claisen head, okay, this is a Claisen head, yung para siyang three-way adapter, is used to allow the addition of a second reagent directly into the reaction flask without requiring the removal of the condenser. So, 1 molar of bromine in acetic acid was slowly added to a mixture of 10 millimoles transenamic acid and 6 ml glacial acetic acid with constant stirring. So, bale yung RBF nyo, yung round bottom flask nyo, may magnetic stirrer yan sa loob, as you will see sa experiment video. So, okay. So, skip ko na to. Yun na rin yung sinabi ko. Okay, slowly drop bromine from the separatory funnel. So, kaya tayo may funnel, yung purpose niya ay para slow lang yung pag-drop ng bromine sa round bottom flask. Okay, after that, after natin ma-obtain yung product natin, we will utilize vacuum filtration to separate the solid product from a liquid with the aid of vacuum. So, vacuum aids in providing a greater rate of filtration para mas mabilis. And we use the Bochner funnel. Makita nyo din to sa experiment video. And the Bochner flask in the setup. So, yung ginawa namin sa experiment video, wala kasi kaming vacuum. Okay? Yung ginawa naming makeshift vacuum ay yung flow ng water from the faucet. So, makikita nyo yun from the setup. Like, instead na vacuum yung nandito, okay, ang nangyari kasi, may flow ng water may flow ka ng water dito. So, parang wala ring nakakalabas na hangin, okay, from the Bochner flask. That's why, mas bibilis pa rin yung rate ng filtration. So, mas makikita nyo to dun sa video. Ayan. So, this is the legit vacuum filtration setup. Okay? So, meron talaga kayong vacuum trap, may, and meron kayong, actually, ito, ganito halos pala yung ginawa namin. So, may water aspirator ka rin, okay? Parang ito yung nagsisilbing vacuum mo for the vacuum filtration. Hindi rin, okay, hindi rin pala legit yung setup na to. Hindi talaga sila gumagamit ng vacuum. Meron lang silang additional Erlenmeyer flask for the vacuum trap. Pero basically, ang ginawa rin nila dito is meron silang water. Okay, may flow ng water dito para yun yung magsisilbing vacuum or makeshift vacuum for the filtration setup. And then we placed a layer of Wattman filter paper that fits the Buchner funnel. We poured the solution to be filtered. Okay? And then, after that, ayun, mafi-filter na siya. And then, for the recrystallization, okay, single solvent recrystallization yung ginawa natin sa experiment na to. So, the crude filtered product must be recrystallized with 50% aqueous ethanol. And then, we determine the melting point using a melting point apparatus na na-encounter nyo na sa experiment 8. Okay? So, this will help in determining which isomer is predominantly present after the reaction. So, the results, okay. So, ito yung mass ng transenamic acid. And then, ito yung mass ng filter paper containing the product. Mass ng filter paper alone. And then, the third will be the mass of the product plus the filter paper. And then, this is the melting point. And then, I also sent the text file for the IR spectrum. So, kailangan nyo din siyang i-graph. Okay. So, for the data analysis, you will calculate the percent yield of the product. Okay. And then, yung FTIR analysis, you will determine the significant peaks and assign functional groups for each peak. And then, the melting point, okay, it will determine the type of isomer predominantly present. So, yun yung melting point yung actually mag-identify kung ano yung major product nyo. Now, to determine the isomer, you will check which isomer has a closer melting point to the experimental value. Okay? So, that's it for our pre-lab for experiment 11. So, do you have any questions? So, may questions ba? So, okay. Kung wala, yung experiment 10 natin, yung functional group analysis, okay, pakita ko lang ulit yung schedule natin. Wait lang. Okay. So, this is our schedule. Okay? So, sa November 12, okay, ipopost namin yung post-lab discussions for experiments 10 to 11. And then, due next meeting yung ATQ nyo for E11. Now, sa Saturday, okay, yun yung unknown analysis. So, i-discuss naman sa post-lab discussion kung paano yung magiging flow ng unknown analysis. But basically, for your unknown analysis, may i-determine kayo na isang compound and then given yung kailangan nyo ma-determine yung solubility class niya given kung soluble or insoluble ba yung compound sa mga solvents. And then, given din yung melting point range. Okay? Hindi yung mismong melting point, pero range siya ng melting points. And then, given din yung IR data, okay, you will determine the significant peaks. And then, fourth, i-determine nyo rin yung, meron din kayong functional group analysis part doon. So, sa functional group analysis, i-determine nyo yung functional groups present sa unknown compound nyo. And then, after that, ayun, i-draw nyo yung structure using Chem Draw or Chem Sketch or pwede nyo rin i-hand drawing na lang. Okay? So, ayun. So, for our unknown analysis, open notes naman to. Okay? Sa Saturday, 1 to 5 p.m. Ayan. So, any questions? Okay? So, kung wala ng questions, okay, i-discuss din naman to sa video, post-lab video, yung sa unknown analysis. So, if you have any questions, that's it for today. Thank you.